All right, well, good afternoon, everyone, and welcome to another exciting day in mathematics. Whoop, whoop. Well, what I'm going to be doing from this point forward, guys, I'm going to go ahead and include the warm-up so that you guys get that practice of the concepts that we've covered, and also that you get the practice on the skill that we need for the lesson. So this is warm-up 110, and it's only 5 problems. Yes, only 5 problems. Number 1, use the binomial theorem to expand, and they give us x minus 1 to the 5th power. Then we got number 2, simplify, and it's got square root of 16a over a, I'm sorry. And we got number 3, solve the system. And then it's a system of 3 variables, 3 equations. First equation is 2a minus 4b plus c equals 0. 4a plus 4b plus c equals 24. And 5a minus 4b minus 5c equals 12. That's so that you can practice on systems. Number 4, write and graph the equation of the parabola passing through the point of origin with a focus of 0, -2 and directrix y equals 2. And number 5, use the given table to write the recursive and explicit rule for the sequence. The n values are 1, 2, 3, and 4, and f of n are 0.2, 0.8, 3.2, and 12.8. So go ahead and copy that, and I'll give you some time. I'll pause the video. Go ahead and pause the video at this time. All right, so home plate for tonight is page 623, all only, page 623, all only. And once again, once you're done with the home plate, and as I mentioned in class, I'm going to give you the extra day for you to turn in. Here's a Nearpod code. Nearpod code is DNWLP. So you guys already know to go to nearpod.com. That code is to join the lesson. And when you log in, since we're going to be doing that just a tiny bit different for your login, make sure you begin with the period number that you were in with me. And then from there, your first name and your last initial. And let me give you an example. Let's say you're in my first period, so you're going to type in 1, and then you're going to leave a space, and then you're going to write Michael J, just like that. And that's how you log in with, that's how you type in your name when you log in. So it lets me know in what period you're in, because I'm only giving you one code for everyone that's taking the course. All right, so you got that? Yes, Mr. Q. All right. So once again, page 623 from your text, and that's your code for Nearpod. All right. So let's get started. Oh, before I forget, if you are not moving forward, then you're already behind. All right. And we'll talk about in regards to the pacing that I was suggesting in class last time we met, and we'll go and get started first with the lesson. And it says, our objective for today, I can identify geometric series. Once again, I can identify geometric series. So if your cousin or your brother, your sister, or your parents are watching the video with you, turn to them and let them know what the main idea is for today. What's the main idea or the main concept? All right, good. So the main idea for today is geometric series. Geometric series. Notice it's a tiny bit different of what we covered last time, so we'll talk about that as we get there. So start a Fourier model, please. And by the way, we are taking Cornell notes, so make sure you get a Cornell note ready. Here's your Fourier model, and our concept for today is geometric series. So get that ready. I'll give you some time. All right, so what is a geometric series? It's an expression formed by the sum of the terms of a geometric sequence. Let me repeat that again. A geometric series is an expression formed by the sum of the terms of a geometric sequence. So first, let me show you the series. Here's a series. But this says in the definition that it's the sum, okay, sum meaning that it's adding, okay, we see that, of the terms, okay, all these individually are terms, okay, of a geometric sequence. So how do we know if this is a geometric sequence? Well, let's see if it's multiplying or dividing from here to here, from here to here. What's happening to 3 to get 6? Happening to 6 to get 12, happening to 12 to get 24, and happening to 24 to get 48. Yep, that's right. We can multiply by 2 to get that number. So if we're multiplying, that means our R is 2. Okay? So that means it is a geometric sequence, but since we're adding each term, that means now it's known as a geometric series. That is correct. All right. Also, you're going to start seeing this, and we'll talk about more of this, but copy this one. This is S of n equals A times 1 minus R to the n over 1 minus R. Only. Copy that. I'll give you some time. All right. If you need more time, just pause the video. So, before I move on, once again, according to the definition for geometric series, it's an expression. Do you see any equal signs here on this? No. And it's formed by the sum or adding the terms of what? A geometric sequence. So did we establish that this was a geometric sequence? Yes. All right. However, I said to copy this, and we're going to be using this today for finding the sum of an actual sequence, and we'll get to that. Let me show you some non-examples. Non-examples given are 3, 6, 9, 12, 15. All right, look at it. 3, 6, 9, 12, 15. All right, turn to whomever there with you and let them know why this is not a geometric series. All right, so I'm pretty sure they said, well, because this one we're adding 3 each step of the way, so that means it's in an arithmetic, and it's not even a series, it's a sequence. Okay, let's go to this next one. 3, 6, 12, 24, 48. You're like, wait a minute, Mr. Q, it looks kind of like this one. Yeah, but this one is a series. This is not a series. Look at it. Think about it. Why is this one not a geometric series? All right, tell whoever's there with you. Maybe it's only your flaming hot Cheetos. Right? So anyways, who saw that even though it is a geometric sequence because we're multiplying times what? Yes, times 2. But is it being added each term? No, there's no sum in between. That's why it's not a series. This is just a sequence. All right, so what can we conclude? What makes a geometric series a geometric series? Think about it. What would be the most important thing to remember? All right, so imagine that you send a snap of this or Instagram or whatever, a tweet or kick or snap or whatever it is you guys do now, and give me some hashtags here. What would you hashtag this picture of geometric series? Hashtag what? Hashtag what? And no hashtag math. Cut it out. All right, so you should have written something to the effect of hashtag geometric sequence, because it does require a sequence, but it also needs to be what? Some of the terms. All right, let's move on. So just to recap, you guys remember when we started with the recursive rule for arithmetic and geometric sequences? Oh yeah, those were fun. And then from there we went to the explicit rule for both arithmetic and geometric sequences. And there they are. However, from there we moved on and we said, so the recursive is the one that's easy to remember, but the one that we needed to work with was explicit rule. And we said that this rule works for any sequence that starts from term number 1. However, we said, what if we start with term 0? It's a little bit different. It's this one for arithmetic and this one for geometric. However, today we're going to focus with the explicit rule only, and only for geometric sequences and series. Let me repeat that again. Today we're only going to focus on the explicit rule for geometric sequences. Let's start with that first. So here it goes. If it's starting from term 0, the explicit rule for a geometric sequence is f of n equals f of 1 times r to the nth power. However, if it's starting with term number 1, we start with what? F of n equals f of 1 times r to the n minus 1 power. And obviously we see the difference from here to here. The only difference is that if it starts from term 1, we always go with n minus 1 as the exponent for r. And if it starts from term 0, it's only n. All right. However, remember when we started with this, I said I'm going to use f of 1 so that we remember that that's our first term. Well, now that we got plenty of practice, here's where I'm going to make the change. We're no longer going to write f of 1. We're going to write a instead. So this will be f of n equals a times r to the n. But we still agree that a corresponds to what? That is correct, the first term of the sequence. Same thing over here. Instead of this, we're going to change the f of 1 for a. So this will look like this. F of n equals a times r to the nth minus 1. All right. So for today, we're going to start focusing only on this one right here. We're going to focus on the explicit rule as if we were starting with term number 1. So it's f of n equals a times r to the nth minus 1. So make sure you remember this. Put a little asterisk, heart, copy that in case you don't have it written down. Pause your video. I'll pause it also. All right. So this is the one we're going to use. Okay. Move on. So here we go. Example 1. Given the sequence, write the explicit and explicit. Oh, I forgot to write rule right there. Write the explicit rule and use the rule to identify the 7th term. All right. So this is a sequence. And what sequences are we focusing right now? On geometric. So let's see if it's a geometric sequence. Let's see. What's happening from here to here, from here to here? That is correct. We're multiplying times 2. If we're multiplying times 2, that means this is our r. Okay. What else do we know? We know that this is our what? Our first term. That is correct. This is our a. All right. And what else do we need? It says here that we need to identify the 7th term. The 7th term. Okay. So first let's write our explicit rule. Our explicit rule for geometric sequences is f of n equals, what was it? F of 1, but instead of f of 1, what are we going to write? A times r and n minus 1 to the n minus 1 power. Okay, so do we have a? Yes. Do we have r? Yes. So let's do that. So I'm going to write f of n equals Ra is 0.25 times, what is our r? R is 2, and then we just write n minus 1. Is this a good refresher? Yeah, right? Okay. But now they want us to find the what? The 7th term. So here instead of n, what are we going to write? 7. So it's f of 7 equals 0.25 times 2. And then we got 7 minus 1. Very simple, yeah? All right, so the rest, I'm just going to do it in black. I just wanted to show you where each piece goes. So here we go. So let's do f of 7 equals 0.25 times 2. What is 7 minus 1? 6 power. All right, so let me scoot up a little bit. All right. So we get f of 7 equals 0.25 times 2 to the 6. I'm going to do 2 to the 6 over here to the side. This piece I'm going to do over here. 2 times 2 times 2 times 2 times 2 and times 2. What is 2 times 2? 4. 2 times 2, 4. 2 times 2, 4. So what is 4 times 4? Right? 16 times 4? Yes, 64. All right. And lastly, we got f of 7 equals 0.25 times 64. Or let me transform this so that I don't do the long, or do you want to do the long multiplication over here? Let me change this. What is 0.25 in a fraction form? 1/4 times 64, which is the same as 64 over 4, which is what? 16. So f of 7 equals 16. Now, this I would get the same number by multiplying these over here with decimal places. All right, so did we answer the question? Let's see. Given the sequence, write the explicit rule and use the rule to identify the 7th term. So did we write the explicit rule? Yes. Did we identify the 7th term? Yes. Now, if you want to check it, you can check it. Just remember, like, imagine you're presenting this to a 3rd grader and tell them, all right, see if you can follow the sequence. 0.25, 0.5, 1. So what goes next? 2, and then 4, and then just follow the sequence and see if the 7th term is 16, and you're going to find out that it is. All right? All right, so keep in mind with your fingers how comfortable you are with these, 1 through 5. Yeah, you should be at 5 right now. All right, because we've been practicing this. All right, so let me give you one for you to practice. Example 1Q. And it says, given the sequence, write the explicit rule and use the rule to identify the 7th term. Pause it and see if you can do that one by yourself. Go. All right, so you should have written f of n equals a times r n minus 1. F of n equals, what is a? 1 times, what's happening from here to here, from here to here? We're multiplying times 3, so that's r. So that's 3 and minus 1. All right, so they want us to find the what? The 7th term, so we just substitute in there. I'm just going to keep it all, but f to the 7th. F of 7, which is 1 times 3, 7 minus 1. F of 7 equals 1 times 3 to the 6th power. And this part, once again, we can do over here on the side. 3 times 3 times 3 times 3 times 3 times 3. 3 times 3 is 9 times 3 times 3 is 9 times 3 times 3 is 9. So what is 9 times 9? 81 times 9. 81 times 9, that's 9, that's 729. Therefore, f of 7 is 729. Bam. All right, how we doing? Good? Bam. Let's go. We got this, yeah? All right. All right, so let's move on. So now that was a good refresher of what we did before we stopped the sequence of lessons. So let's go to the next one. Example number 2. Look at this one. This one's interesting, though. It says, given the sequence, write the explicit rule and use the rule to identify the number of terms in the sequence. Now, this one, they don't tell you to find the specific number in a term. They want you to name how many terms are in the sequence. However, they still want you to write the explicit rule. So if this is a geometric sequence, what was the process? All right, so let's see again. What's happening from here to here, from here to here? Yeah, times 2. So we see that it is an R. All right, so if we write our explicit rule, we write f of n equals a for the first term times r n minus 1. All right, so now it's a little different because now we need to figure out, what do we need to figure out? How many terms? We don't know. However, we do have information here that we can substitute in there. We have the first term, okay, that goes right here, 0.25 times, what else do we have? The r, which is 2, that is correct, times 2, okay. I'm going to write n minus 1, okay. However, we do have f of n of our last term. What is our last term? 16. So 16, I'm going to write it here. And if you want to sketch an arrow right there, and the first term, you already know that the first term goes here. And the r, we know how to get the r by the sequence. I'm going to pause it and I'm going to give you a little bit of time to copy that. All right, so we need to figure out n. How do we figure out n? Well, let's isolate the 2 so that we can leave the n by itself. So if the 0.25 is multiplying, what is the inverse? That is correct. So that means we're going to divide by 0.25, divide by 0.25. Okay, so we're done with that. And I have 16 divided by 0.25 equals to 2 to the n minus 1 power. Okay, so this division, let's see, I'm going to do the long division over here. You want to do long division with decimals, or do you want me to change this to a fraction? I'm going to show you both. So 16 divided by 0.25. Move the decimal twice, add 2 zeros. So we no longer have a decimal here. 25 into 1, no. 16, no. Into 160, yes. That's how many times? That's, is it 6? 6 times? Yeah. 6 times 5 is 30. We got 3. 6 times 2 is 12. Plus 3, that's 15. Subtract, that's 10. Bring down the 0. 25 into 100, that's 4. That's 100. Subtract 0. All right. So this is 64 equals to 2 and minus 1. All right. So notice that this is a little different because this one doesn't have a power. This one has a power of n minus 1. We need to figure out what n is. What is n? Okay. Because that's what they're asking us to figure out. What is the number of terms in this sequence? So one thing that they do give us, notice that here the r, which is 2, isn't it a base? Now let me review that with you. Whenever you are given an exponential expression, this number is known as the base. This is the exponent, so base is 2. So can I rewrite 64 using the same base? Yes, let's see. Let's see if it works. Let's see. And check this out. I'm going to take you back to elementary. Since I'm using base 2, can I divide 64 by 2? Yes, that's 32. Circle the 2 because that's a prime number. 32, can we divide it by 2 again? Yes, that's 16. 16 divided by 2, that's 8. And 8 divided by 2 is 4. And 4 divided by 2 is 2. All right. So how many 2's do you see? 1, 2, 3, 4, 5, 6. So I'm going to write 64 like this. 2 to the 6th power. Do you agree with that? Yeah, because if I multiply 2 times 2 times 2 times 2 times 2 times 2, it gives me 64, or 2 to the 6th. All right, bring down the rest. This is 2 and minus 1. You're like, oh, I think I see it, Mr. Hugh. I know, right? So if they have the same base and the exponents should be the same, but this one has n minus 1, this one has what? 6. So I'm going to focus right here. Check this out. I'm going to focus right here. I'm going to write this on the side. 6 is the same as n minus 1. So we just need to solve for n so that we can know what the term was. So let's see. We do plus 1 plus 1. So 7 equals n. You're like, man, that's a lot of work, Mr. Q. I know. But you know what? We need this in order for us to get to that next part, which is the main lesson for today. I'm just kind of like tic-tac-toeing this so that you understand all the parts. So let me go back and recap this just to make sure we got it. So we started with a sequence that they didn't give us all the terms, but they gave us the first term, they gave us the last term, and there's some terms missing. And the question was, how many terms does this sequence have? How many terms did we find out it had? 7. What did we use? We used an explicit rule. There it is. Substitute the last term for f of n. Substitute the first term in here for a. Substitute the ratio, common ratio for r. And then once we had that, we needed to isolate the base with the exponent. So like that, we can identify by writing it with the same bases, both numbers, this one, same basis, and we just compare the exponents, and that's how we can solve for the missing term. All right, are we doing good? All right, let's see how you do with 1. Y'all ready? Pause it in case you haven't finished copying this. I'm going to pause it. All right, and we're back. All right, example 2Q. It says, once again, given the sequence, write the explicit rule and use the rule to identify the number of terms in the sequence. The sequence given is 1, 3, 9, ... 729. Copy that and see if you can do that one by yourself. Remember, we just need to find out how many terms this sequence has. But you still need the explicit rule. Go. I'll pause this. All right, so let's see how we did. First things first, we have what? A. Okay, what else do we have? What is the common ratio? What's happening from here to here, from here to here? Times 3, and that's our r. Okay, so let's write our explicit rule. F of n equals a times r n minus 1. So to get started, we have a. A is 1. So that goes right there, times, what is r? 3, that is correct. And what else do we know? We know the last term. What was our last term? Our last term is 729, that goes right there. And then we just write n minus 1. All right, so let's get started. We divide by 1 each side. Divide by 1, divide by 1, so we're done with that. We're still left with 729 equals to 3n minus 1. All right, so what is our base? 3. So what does that mean? Let's see if this one can be divided by 3. All right, so let's see. 729 divided by 3. So let's see. 3 fits in here how many times? Twice. Carry 1. 3 into 12 how many times? 4. And no carries, and 3 into 9, that's 3. Okay, we're done with this 3 because that's a prime number. And let's try it again. Does 3 fit into 43? Let's see. Into 2? No. How about into 24? Yes, that's 8. And how about into 3? 1. Okay, so circle that one. Let's do it again. 3 into 81. Circle the 3. 3 into 8 how many times? Twice. And we have how many left over? 2. 3 into 21. Here's the 21 right here. Do you see it? Yeah, that's 7. All right. Do it again. 3 into 27 how many times? 9. And then lastly, 3 times 3. All right. Okay, I think we got it. And you know what? I'll do the work right there next to it so that I don't have to slide over. All right, so let's rewrite this. So this is how many 3s? 1, 2, 3, 4, 5, 6. So this can be written how? can be written, yeah, I'm going to write it down here. I just don't want you to lose the sequence over there. So 729 can be written as 3 to the 1, 2, 3, 4, 5, 6 power. And that is equal to, what is on this side? 3 and minus 1. All right. So therefore, since they have the same basis, what do I need to do to figure out what the term was? Focus on these. Is that correct? So what do I write? 6 equals n minus 1. Therefore, what do? Plus 1 plus 1, 7 equals n. So how many terms does this sequence have? It has 7 terms. All right. Show of hands. Well, I can't see you, but just show of hands by yourself. Make it a high five. Bam. All right. So we got this. Yes. Now this is one step closer to what we're going to be doing today. Right now, notice we still were on sequences. You guys notice that sequence, and it was a geometric sequence. All right. And by the way, this what we just did right now, I don't know if you noticed, it was fairly simple if you think about it. It's just work, but it's fairly simple. This is a really close step to what we're going to be doing with logarithms, which is same thing. It's fairly tweezy to do. All right, go to the next one. All right, look at this one, geometric series. This formula for geometric series is given so that we can find the sum of a geometric series. That's why it's S for sum, and for the number of terms equal to A. We know what A is. Is that correct? Yes, the first term. Parentheses, 1 over R to the nth over 1 minus R, close parentheses. So let me repeat that again. S of n equals A times 1 minus R to the nth over 1 minus R, close parentheses. Copy that because we're going to need that for the next problems. I'll give you some time, or you can pause it at this time. Come on, tomatoes. All right. So keep this one in mind because we're going to be using that in a little bit. Look at this next problem. Problem number 3, example 3. Use a formula to find the sum of the series. Let me repeat that again. Use a formula to find the sum of the series. Notice this one doesn't say sequence anymore. We're already in series. What does that mean, Mr. Q? Well, that we're going to be using this formula. Does everybody see that? Okay. All right, so what is it that we need from our formula? Let's find out again. What did we say A was? That is correct. This is our first term of a series. All right, what else do we need? We need our what? Very good. Our ratio, or our common ratio, which is the pattern that we always find. Is that correct? Yes, but this one has now something a little bit different, which is this. This n and this n. This n and this n is the number of terms in the series. Number of terms in the series. Once again, number of terms. Label that on the one you copied, please. N is a number of terms, A is a first term, and R is a ratio. All right, let's look at the problem given. Here it is. Use a formula to find the sum of the series. The series given is 1 plus 3 plus 9 plus 27 plus 81 plus 243 plus 729. Okay, so what is it that we need? Well, we need our A. Do we have our A? Yes, our A is that one, first term. Okay. What else do we need? We need our ratio. What's happening from here to here, from here to here? If this was a sequence, what happens to get that number from here to here? That is correct. We're multiplying times 3. So this is our what? Our R. Okay. And what else do we need? We need the number of terms. How many terms does this one have? 1, 2, 3, 4, 5, 6, 7. So our number of terms is 7. Now that we have our information, let's write our formula. S of n equals a times 1 minus r to the n over 1 minus r, close parentheses. You're like, Mr. Q, this is easy. I know, I'm telling you. So let's substitute values. What goes here for a? 1. What goes here for r? 3, because that's our common ratio. So this is 3 and 3. Okay, let me bring everything else down. The S of parentheses 1 minus, and then I got over 1 minus. However, instead of n, what are we going to write? That is correct, our number of terms. So this is 7 and 7. And that's it. All the rest of it is just computation. So now that I did it in color, I'm going to do the rest in black so you can see the computation. This is S of 7 equals 1 times 1 minus. I'm going to do this part over here. Let me do that in red. This is the same as 3 times 3 times 3 times 3 times 3 times 3 times 3. 2, 4, 6. Okay, so this is 9, 9, 9, and then times 3. This is 81 times 9 times 3. 81 times 9, that's 729 times 3. 729 times 3, that's 27. I got 2, 6, 7, 8, and that's 21. So this is 2,187 over 1 minus 3. All right, let's simplify. I did this function, sorry. S of 7 equals 1 times, what is 1 minus 2187? That's negative 2186 over, what is 1 minus 3? Negative 2. All right, so let's see what that looks like. All right, so we got S of 7 equals 1 times, what is 2186 divided by 2? So 2 divided by 2 is 1, and negative divided by negative is positive, so this is 1. It doesn't go into 1, that's 0. How about into 18? That's 9, and into 6, that's 3. Therefore, S of 7 equals 1093. And what does that mean? What is the sum of that sequence of 7 terms? That's what it means. What is the sum of that sequence of 7 terms? 1093. All right, and you can check it by doing what? Adding all these together. You can stack them up, add them up, and guess what that's going to give us? 1093. But I'll let you do that on your own. All right, show me your fingers. How come you're all with these? Good. Yeah, it should be at 4 or 5. So here goes the process one more time. Identify the first term, identify your ratio, and identify the number of terms. Write your formula, substitute values, and simplify. All right, let's see how you do. And once again, if you're taking notes in regards to the process, make sure you write your steps. Remember your steps. What is the first step? Identify A, R, and N. What is step 2? Write your formula. Step 3, substitute values. And step 4, simplify. All right, do this next one by yourself. Example 3Q. Use the formula to find the sum of the series 0.25 plus 0.5 plus 1 plus 2 plus 4 plus 8. Copy that, and I'll give you some time, or pause the video right now. All right, so now that we're there, what is the first thing we needed? A, which is what? 0.25, that's our A. What else? We need our R. What's happening from here to here, from here to here, here, times 2, and that's our R. Okay. And what's the only thing that's left? Our N. How many terms in this series? 1, 2, 3, 4, 5, 6. So our N is 6. All right. So step 1 is done. Identify those values. Step 2, write our formula. What's our formula? S of n equals a times 1 minus r to the n over 1 minus r, close parentheses. And all we have to do is substitute values in here. So here we go. S of, I'm going to leave an open parentheses, equals, what is a now? A is 0.25 times 1 minus over 1 minus, what is our r? Our r is 2 and 2. And what is our n this time? Our n is 6 and 6. All right. Check yourself to see if you got that. All right. So now I'm going to finish the rest in black. S of 6 equals 0.25 times 1 minus this. You can do over here on the side. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 times 4 is 64 over 1 minus 2. S of 6 equals 0.25 times 1 minus 64, that's negative 63, over 1 minus 2, that's negative 1. All right. All right, so S of 6 is equal to 0.25 times 63. So let me do that over here. We got 63 times 0.25. 5 times 3 is 15. I got 1. 5 times 6, that's 30 plus 1, 31. 2 times 3 is 6. 6 times 2 times 6 is 12. And 0, 0. We got 5, 7, 6, 1. How many decimal places? 2. So therefore the sum of these 6 terms, series, is 16.75. Check yourself to see if you got that. Oh wait, I think I made a mistake. Who caught it? All right, so yeah, so here is 3 plus 2 is 5. This is 5. 3 plus 2 is 5. So this is 15. Yeah, I did that to see if you were paying attention. All right, so pretty much, if you notice, it's a piece of cake up to right there, and now we're ready for the next example. Example number 4. Copy this. Use a formula to find the sum of the series. 1 plus 3 plus 9 plus 729. Copy that. All right, so example number 4, let's see. It says, use a formula to find the sum of the series. 1, 3, 9 plus 1 plus 3 plus 9 plus ... 729. And we're like, wait a minute. Well, let's first label stuff that we have. We have our first term, A. There it is. Okay. We have what else? What's happening from here to here, from here to here? Yeah, times 3. So we have our what? R. Okay. All right, so then next we need the number of terms. So we need n. Oh, wait a minute. We don't have a total number of terms because we only have 1, 2, 3, ... all the way to 729. So how do we figure out the number of terms in a sequence? You're like, oh yeah, remember, Mr. Q. Yeah, because we did that earlier, right? We're supposed to use the explicit. Yes, the explicit form. So what do we write? So I'm going to find this part. I'm going to do that over here in green. Let me zoom in. So to find the number of terms, let me rewrite that again. find the number of terms, that's what we need here. We need to use the explicit form, which is what? F of n equals a times r n minus 1. You guys remember that? Oh yeah, we did that earlier. Yeah, that's why we did that practice, so that we can find this part. All right, so let's substitute values. What is a? 1. What is r? R is 3. And then we have f of n equals 2 n to the n minus 1 power on the 3. All right, so then we need to figure out this part. So what did we say we were going to substitute for f of n? Yeah, the last term. That is correct. The last term goes here. So this is 729 equals, I have 1 times 3 to the n minus 1. All right, so let's isolate that base. And what do? Divide by 1, divide by 1. So we have 729 equals 3 to the n minus 1. All right. All right, so therefore, what does this mean? That we need to write this one to the base of 3. So what do? That is right. You guys remember that? When we divide by 3, yes, it's in there twice. Carry over 4, and then 3. Let's see if we can do that again. 3 fits in here, 20 into 24 8 times, and into 3 1. 3 into 81, that's 27. 3 into 27, that's 9. And then 3 times 3. All right, so therefore, we can rewrite 729 how? What's the base? 1, 2, 3, 4, 5. The exponent of 6, but base of 3 to the exponent of 6. Bring down the equal sign, and that's going to be equal to 3 to the exponent of n minus 1. Now we can figure out our n. How do we figure out our n? So if both of them have the same base, we just need to focus here. So we end up writing what? 6 equals to n minus 1. That's it. All right, so therefore we solve. So this is plus 1 plus 1. So we end up with, let's cancel, 7 equals n. All right, so now we have our value of 7. All right, let me zoom out. So now we actually just do what? Yeah, we just do our formula. And by the way, I don't know if this came out on the video. It should have, but it might have been cut off. Sorry. There it is. I'll leave it up there so you can copy that. Copy that for a little bit. All right. So now that you have that, let me zoom out again. All right. And the rest we already know what to do. We write our formula. S of n equals a times 1 minus r to the n over 1 minus r, close parentheses, substitute values. S of equals 1 minus 1 minus. All right, so then we said it's the 7. Well, let me start with the r. R is 3 and 3. And a is what? 1. And then the n, we said it was 7th power. 7th power. All right, and then the rest we just simplify. S of 7 equals 1 times 1 minus 3 to the 7th. And didn't we do this one already? Yeah, right? So this is the same as 3 times 3 times 3 times 3 times 3 times 3 times 3. 6, 7. So this is 999 times 3. This is 81 times 9 times 3. This is 729 times 3. So this is 27. We got 2. 6, 7, 8, 21. 1. So this is 2,187 over 1 minus 3. So S of 7 equals 1 times 1 minus that is 2,000. It's negative 2,186. And then 1 minus 3, that's negative 2. So the sum of the 7-term sequence is this divided by 2, which is, let's see, 1, 0, 9. Did we get that earlier? Yeah, there it is. So what's the only thing that we needed to do? We needed to find the n by doing what? The explicit form to find our n. And then substitute all values into it. You're like, now I get it. I was getting lost on the book. Yeah, I know. All right, so then for you to practice, see if you can do that one by yourself. Example 4Q, use the formula to find the sum of the series. 0.25 plus 0.5 plus 1 plus ... 8. And once again, I'll let you do that by yourself. And the last example that you're going to get in the book is this one. Find the sum of a geometric sequence that starts with 3. What does that mean? That 3 is our what? A. And it ends with 96. What is 96 if it's our last number? That's our F of n. And then a common ratio of 2. So this is our R. So what is the only thing that we're missing? We're missing our n again. Is that correct? So that means we need to find our n by using the explicit, and then from there getting the sum of the series using the formula. Pretty simple. Like I said, this is basically the one we just did like this. It's the same thing. What is this one? They gave us A, they gave us R, but they didn't give us n. They gave us A, they gave us R, but they didn't give us n. And on this one, they do give us n. And they give us the last term that we need for this part. All right? All right, so let's see how you do with that. Once again, your home play for tonight is on page 623, and there's a code for Nearpod. All right, I know I went a little bit long. I probably would have split this into two lessons or 2 days, one for practice on certain parts and then the other part the following day. But since you guys have plenty of time, enjoy it, guys. Once again, stay inside, clean your room, help your parents clean the house, and wash the dishes and cook for them. Bam, make some tortas. Let's go. All right, have a good one. See you guys till later. Bye.